Hey, it looks like it's time to find the inverse of a function. So we got a friendly little function. First thing I want to do to make life a little bit easier is I want to replace f of x with y. Then I make x and y trade places. Solve for y. Now, let's rewrite it as an inverse function. Right, so if the original function f of x is 3x minus 7, the inverse function of x is x plus 7 over 3. Please do not confuse this with plain old numbers with exponents. Right? F to the negative 1 does not mean that I want 1 over f. Right? I'm not doing a reciprocal. I'm doing an inverse function. Right? In function notation, that negative 1 is not an exponent. It tells me it's an inverse function. Let's take a look at another one real quick. Hey, this one is g of x. Okay, again, swap it out for y. Swap the x and the y. Solve for y. So we multiply both sides by 8. Add 5 to each side. Finally, rewrite it as the inverse. So inverse function of g, 8x plus 5. Okay, again, you're saying, hey, it's pretty easy. Let's make it y equals x squared minus 2. Swap the x and the y. Solve for y, so we'll add 2. Remember, when we take the square root, we got to put the plus or minus there. Rewrite it as inverse function. And you're saying, oh, this is all a piece of cake. Let's get to the assignment. Well, let's take a little bit of truth serum here. That first example was a function, and the inverse was also a function. That second example was a function, and the inverse was also a function. That third example was a function, and the inverse, the inverse is not a function. Now, what's the easiest way of telling whether or not a relation is a function? Well, let's go to our friend Desmos. Right? Vertical line test. F of x is obviously a function. F inverse of x is obviously a function. Right? If I put a vertical line going straight up and down the paper, I never hit either function more than once. Before we look at g of x, I want to add one thing to this picture, though. Look at the line y equals x. F of x and f inverse of x are mirror images of each other, with y equals x being the line of symmetry, or the line of reflection. And notice that where f of x and f inverse of x intersect is on the line y equals x. G of x, if I draw vertical lines, I never hit that more than once, so it's a function. G inverse of x, again, if I draw vertical lines, I never hit it more than once, so it's a function. And again, if I add the line y equals x, that again is the line of symmetry between those two functions, or I should say line of reflection. So if you are inverse function, you should be a mirror image of the original function. Okay, the issue with h of x. The original is a function, it's a parabola. I can draw vertical lines, never hit it more than once. But if I look at the inverse function, sideways parabola, vertical line can hit that more than once. So h inverse of x is not a function. It's still a relation. It's still the inverse of the function h of x, but it's not a function by itself. Notice when we add that line, y equals x, sure enough, they are mirror images of each other, right? The line y equals x is the line of reflection for those. And again, any place that h of x and h inverse of x intersect is right on that line y equals x. Right. Most of the time we can find the inverse of a function, but most of the time the inverse will not be a function. That's probably the most likely situation. Sometimes we find the inverse of a function, and indeed, how lucky can we get the inverse is a function? That will happen almost all the time if it's a linear function. Of course, the only problem with a linear function is that a vertical line is not a function, but any other line besides a vertical line is a function. So if we start with a non-horizontal, non-vertical line, we'll end up with a inverse that is not horizontal and not vertical, and so both of them will be functions. And then every so often, holy cow, something weird happens and you cannot find the inverse. Most of the time we're going to be able to find the inverse. I don't plan on stumping you or doing something wild and crazy, not in Algebra 2 at least. And indeed, if a function does have an inverse, y equals x is the line of reflection. Okay, enough of these easy examples. Let's try a messy one. Make sure we really understand what we're doing. Okay, so we replace k of x with y. We swap x and y. What do we do first? Well, it looks like we should multiply both sides by 4. Perhaps subtract 3 from each side. Undo the square root by squaring both sides. Math man, today is the day. I say math man, let's multiply this way. It's fun to F-O-I-L. Right, get out on that disco dance floor. And then, of course, we need to add 5 to each side. And then how lucky can we get when we divide both sides by 2? All those were even numbers, and so they're all divisible by 2. And we end up with 8x squared minus 12x plus 7. Whew, a lot of algebra there. That was fun. So the inverse function of k of x is 8x squared minus 12x plus 7. Better go to our friend Desmos. We're going for the real dramatic situation here. I've got my original function k, my inverse function k of x, and Desmos, well, there's k of x, because we know how to graph the square root function, and k inverse of, whoa, what happened? Those don't really look like mirror images of each other. What's going on here? Right, if I draw that line, y equals x, I'm thinking, something's going on with the domain and the range. Therein lies the issue. Right? With the original function, the domain becomes the range of the inverse. The range of the original function becomes the domain of the inverse. And so we've got an issue with the domain and the range. With the original function k of x, I've got a situation where because it was a function, each x only corresponded to one y. So half of the set of points that will appear to be in the inverse really should not be there. All right, so I'm going to do a real quick inverse and try to point out exactly what just happened there. Right, if the original is x plus 3, the inverse is x minus 3. And if I make an input-output table, it's pretty easy to say, okay, for the original function, you're just adding 3, and I can see what the numbers are doing. But then on the inverse, it's x minus 3, and look at what has happened. The domain and the range have swapped positions. And so that's what was going on with that square root function. Right? The inverse function actually looks like it's the inverse of if the original k of x had a plus or minus in front of the fraction. But it does not have a plus or minus in front of the fraction. And so k of x should not look like a sideways parabola, and therefore k inverse of x should also not look like an inverse parabola. All right, so if the original function's a line, the inverse will be a function, of course, as long as we're not looking at a vertical line. The inverse will also be a line, and the graph's going to be a perfect reflection. If you start out with a parabola, the inverse won't be a function. It's going to be a sideways parabola, but the graph will look like a perfect reflection. Now, the tricky part, if the original function is a square root, the inverse is going to be a function, but the inverse should only look like half of a parabola. And if I use a graphing calculator, I'm not going to see that accurately. Now, I've got both a worksheet for you to work on, and then, of course, I've got some IXL that can be done as homework. And you're going to notice something when you get to the IXL. If the original is 3x minus 7, I'd like to show the inverse as x plus 7 over 3. To me, it's very obvious when I view that those are inverse functions, because one of them starts by multiplying by 3, the other one finishes by dividing by 3. One of them has the last step of minus 7, the other one has the first step of plus 7. It's pretty obvious to me that those are inverse functions. But IXL won't write them that way. They're going to clearly show that the original function is a straight line, and of course, the inverse function is a straight line, and they're going to write it in slope-intercept form. So instead of x plus 7 over 3, when you're on IXL, it's going to look like 1/3 x plus 7/3. Right? I happen to prefer leaving it together as one fraction. I think it's more clear that it's an inverse of the original function. But the way IXL does it, it's much more obvious that they're both lines. They're both linear functions. They're both got a slope. They both have an intercept. Again, for IXL, a score of 80 or higher will be considered as full credit. And you'll just be, a lot of the questions are just yes or no, whether you're looking at inverse functions. Highly recommend you work on the worksheet first, get feedback from that while you're in the classroom, and then if need be, if IXL does not get finished in class time, you can complete it at home for homework.